welcome to the Synera Basics training. Just also for Tobias, quick introduction. I'm Marvin, I'm head of Academy at Synera and responsible for onboardings, for on-site trainings, and for all the documentation in the software, for all the training data, material, and tutorial videos. Today we want to dig into Synera from a learning perspective, so also for the Altair participants. We'll have a little introduction, but then we will really dig into what are the features in Synera, how is the user interface look like, and how do we drag wires, how we build up low-code workflows in Synera. That is particularly interesting for new users who have no knowledge of Synera at all. So I'm trying to answer these very first questions. That mean we focus. We have a very clear focus, and we might leave out some things left and right, not to be overwhelmed and to get used to the very basics. If you have questions, we will have some place in between, some breaks also, but please just ask in between if there is something, and then we can get to that. Yeah. So we will start. Yes, Praveen?
Just to mention, we will have about 1.5 hour session, and then we'll have a break, right?
Round about like a two after 2 hours.
After 2 hours, correct. So we'll have a 2-hour session, then we'll have a break, and then we'll have the second half of the session. You can feel free to mention your questions in the chat or unmute yourself and you can ask. And we will make sure that we address those questions. Let's keep it interactive. And I don't know, do you want the videos to be switched on or switched off, Marvin? Just to make it more interactive and make sure that you see some audience.
Yeah, it would be nice. Yeah, at the moment I see like a small version of the WebEx interface, and yeah, I think that's nice. It'd be cool. Also the chat. I don't know. Can I view the chat?
Yeah, you can. You see, you have the
video.
Or
the moment I don't see, but maybe can just get started, and please you can write in the chat.
I have made you the host. Can you see it now?
No. It's probably because I share. It's just a very miniature version of that interface.
Is it okay? No problem. I can take care of the chat. So if there's any questions, I can let you know. So we have 7 participants now. Okay. Yeah, I think it's now 8. So yeah, I think we are all good to start.
All right. Cool. Thank you. Yeah, I gave a little introduction. I think that should be sufficient for now. So we will start with a brief intro. What is Synera? Then we will dig deeper into the Synera basics. We will have a break after that session. So that is I would say the main session for today. Afterwards, we will get to more advanced topics, but for this, it's also required to lay a little bit hands-on, to test it yourself, to explore a bit. We will do so. That is an interactive tutorial here. So you will get the first hands-on like connected engineering using the CAD connectors. So we want to connect CAD and FEA in a more effective way. Then we'll give you some outlook, because as I said in the beginning, we will focus a lot because that is only the basics of Synera. So I want to give you a quick outlook what you can do also as an advanced user. And then in the training data that are available and download in I think Praveen put the link in the chat. You will also find this challenge. It's a homework. So it's a parametric CAD and FEA workflow based on a simple I-beam. I will give you a little introduction, and that you can take home with you and test your knowledge, what you've gained before. We have the closing in the end. So what I want you to take out of this session is understanding the added value that Synera brings. We want to learn the software basics, the basics of the UI and UX, so that you're familiar to navigate in the software, and the basics of workflow creation. We want to understand the capabilities of FEA automation and then explore a little bit the tool stack so you get an idea what's beyond the horizon of that. All right. At the end, of course, yeah, these things are to manifest that. So I really, we'll get to this later, but advise you also to create an account, a Synera portal account, because there we have a huge library of online learning materials. There is some also at the Altair learning portal. However, we have much more in the internal one because we also run a internal quality assurance and so on. And yeah, so we suggest you to do that because you can use that along with the software in an interactive mode. All right, then let's get started with the introduction. So what's the world, how does the world look like we live in today? What we see a lot in the industry is that work is sequentially. So it's one step after another. It's a linear process. And along this process, usually, especially in larger companies, there are a lot of departments and teams involved, and sometimes even different offices and different locations. So from office to office, from location to location, of course, data need to be sent, there are interfaces, and the chance is really high, especially when the company is large, that those silos are created, silos where people are blocked in, they're trapped in the silos, and it's very hard to send information or to gain the information, get the information from other silos. Teams are more or less disconnected, but that is really a pain when you want to have a process that runs through smoothly. So yeah, there's a lot of waiting time involved. Designers wait for the FEA simulations. The simulation experts are waiting for design updates and so on. And when we speak about experts, we also see that when we use expert software, then usually it's it very much relies on these softwares, on these software tools, on the specific experts, on the people. So when they are ill, when they are on vacation, when they are retired, sometimes the knowledge is just gone and we can't access that. So that is also a problem and something that that hinders us from moving along and having a smooth process. So how can this be accelerated? First, like what does the industry do at the moment? How do we tackle these problems? The first thing is manual work. So in-house, we could, for example, train other people. We can also hire new people. The nice thing is that we have the access in-house, but the downside is that it's very hard to scale. People have an onboarding phase of several weeks, months, maybe. After half a year, they are like really into that. And it's also expensive. So we can outsource. That's common method. So that's way cheaper, easier to scale. You can say like, we lower the project, we ramp it up. But also the people on the other side are usually not so related. Their passion is not with the product and with the company. It's a job they're working for another company. So quality might be lower, and you also have the overhead management. So we can go in a different direction. We can automate stuff, and we can first look at the experts. So TCL scripts, Visual Basics, all this kind of stuff. We could automate single steps, but as I said, it's very dependent on these programmers, on these script writers. Often engineers can also do that, but it's not super common. So not all the engineers or the designers, for example, in FEA a little bit more probably, but not all the designers are familiar with scripting and programming. So when you have an expert tool, it's nice. but you also need the expert to maintain the tool. Then scripts across tools. So I mentioned that in the very beginning, in my background, like when the core team of Synera used to do engineering services, lightweight design, we used to work with a lot of different companies. There were different projects, different tools involved, and we used to automate across these tools with scripts. So that is nice because it's also free, but again, it's related to a person that is very skilled in Python in that case, or in other languages. Also, it lacks of integration. So then you've set up everything for one nice process, and then another customer uses another FEA solver or uses another CAD tool. Yeah, you have to rewrite that. You have to adapt that. These tools are sometimes not open, so it's very hard to do that actually. And in scripting, we always lack of visualization. So it's a nice code, but yeah, in both CAD and FEA experts need a visualization. You want to turn the model, you need to look at the hotspots and so on. So what would be a perfect world for us? First of all, it should be easy or easy accessible. So also the CAD engineers could have access to at least some more simple FEA setups. Maybe they don't understand everything that's under the hood, but they should be able to use that and do some estimative analysis themselves, for example. Should not be should not rely on the other department and then wait for 2 weeks for that expert. Then we're using sharing and scaling. When you once set it up, I talked about that before, about the Python automation across scripts. So when you have another project, it should be super easy to adapt all that work that you did to the new project. And that to minimal cost, meaning very quickly. And yeah, that goes into repeatability when scaling. So yeah, you have one workflow and you want one process, and you want that in the whole company to be used, to be shared. That needs a very easy and also transparent way to look at these processes, to set them up and make them approachable for the engineers. All right. So how did we tackle that? We are on this way. So these are some of our goals. As once said in the beginning, so the core team from Synera comes from a research institute where we used to work together with a lot of industry partners from automotive, aerospace, mostly mechanical engineering, consumer products. You can see some of the customers on the left side. So now we also have engineering service providers. That is yeah, not so common before. So we used to really like have the part as an output, and that is also something from, I would say, the tools that you are probably used to. So you work in SolidWorks, you work in HyperWorks, and it's always the part. So you always look at the part. You model at the part, and the output is a part in the end. Then you just integrate a nice report and you send this over. This has totally changed. Just so that having some working students at our company, it's super interesting. So when I used to study mechanical engineering, and the output was always a part. And now they are on the same age. They are in the beginning of the 20s, so they create something. But what they hand over with a thesis, or also to a customer of us, that is a workflow. That's a process. It's not the part. And a small but very powerful difference is that the part is something very static, but the process is something that can be easily in our software adapted to other projects to be reused for another problem that will come up. So that's a little excursion I took here. But with this idea, because we were tired of automating everything by scripts, but still wanting to be everything connected and keeping the process in the focus, because it's not the part that people are very skilled in the industry to create really good parts. It's the process that is their problem, because it's too slow and the interfaces are lacking. So we founded the company in 2018 to make this approachable, to make this easier for the companies. We are related. We are located in Bremen, our headquarters that is in the north of Germany. But as you can see here, we are a very multicultural team, and we are also remote first. So a lot of people are sitting all over the place in Germany. At the moment, it's around about 50, 60 people. Okay. Then let's go slowly in the technical direction. Here on the right side, you see a first image, a first glimpse on our product. At first, yeah, you hear that now a lot of times. We want to leverage automation. Automation is the key for us. We want to make this accessible and to automate product development processes. So especially for US Altair Partner Alliance users, there is a special installer, and this installer is equipped with all the tools that are also available in the Partner Alliance version, so all the partner products. And our main, you can see that already here, our main nodes, so each of these small boxes is called a node. We will get to that later in depth, but it's a functionality. And with some of these nodes, they are connectors and they can connect to external software. For example, HyperMesh and OptiStruct, so for meshing and optimization and analysis. And that allows us to create a digital workflow on the canvas that you can see here in the user interface. So we still see our part on the right side. Everything is still visible, but on the left side, that's where we work 90%, and that is where we create this workflow. Right, I already talked about, so that's the canvas. It's a canvas where we set up the workflow, and on the right side, all the time in the process, we have a 3D visualization of what we do. Okay, so you're not the first one who starts with Synera. Seen in the slide, 2 slides before, there are a lot of companies, mostly from automotive, aerospace, consumer products, mechanical engineering, the engineering service providers use it a lot, especially now, for automating stuff. So some have really like small departments or teams who are even called sometimes connected engineering or generative engineering in the past, and are focused on automating their processes. All right. We'll get more technical and technical from slide to slide. So this is one of our case studies, one of the customers that use Synera as an advantage. So a company is called Voigt, and they have different branches, but this branch does big paper machines for paper production. And in these big machines, they have these kind of roll brackets. So there is a lot of design variants from these simple brackets, and they need to be analyzed, and that is a very repetitive and tedious task because more or less they look the same. They need to be analyzed and further optimized. So doing that for each of the variations is a very time-consuming task that can be automated especially because they are so similar. So what they did is they set up this workflow in Synera connecting CAD and FEA. And in Synera, you can see that on the right. You also have the ability to document stuff. You can paste GIFs, images, and you can describe everything with text. So you can also use different groups and colors to make it organized in a way. And they did this in a very easy, approachable way so that also the CAD engineer can open that file. They don't have really an understanding of all the FEA stuff, but they can import their design spaces, their parts from this bracket, do some simple settings, and then let the workflow do the job. So everything, and that's also one of the the key learnings, like how to set things up in Synera, everything that is related to the geometry, to the technical specification, just comes all the way to the left. There you control the whole workflow. And then you have the workflow on the right who does the job, who gives out in the end the result. So they did this very smart. So they have a guideline, and in this guideline they describe which of the colors, which of the attributes they need to give to certain surfaces in the model. And when they import it, these colors can be read out, and on the surfaces, then the loads are applied, the boundary constraints are applied, so that it doesn't really matter what kind of part you have here. You can come up with certain logics, parametric logics that also take into account the size of the bracket to give, for example, an element size that fits for all of them, or the element size is calculated for the designs. A small bracket needs a smaller element size, a larger one needs a larger, and so on. So they set up this logic and then just feed in all these brackets so that they can be calculated automatically. Yeah, and as you can see here, so yeah, they from their side, that was a huge success because they can automate this this process, and yeah, big time saving factor, especially for this repetitive task. When we write this down, and that's also I want to jump a little bit. Like imagine imagine yourself, you're using Synera in your projects in a company. How would you deal with it? So first, it's really important just to write down the steps. What is actually required along this process? So we usually start on the left with some input data. We get the geometry, or we have created the geometry ourselves as CAD designer. Then, of course, the material and some load steps are required. Here we can talk to our FEA expert and they can give it to us. Then we have some reference geometries. So as I said, we extract some geometries from these parts, and here that's the heart of the parametric process. We do it in a way that it works for all the variants. We will test it with a few and then check it out in the process. Then comes the FE setup. So here we have our boundary conditions and the meshing that all goes into FEA solver, and that solves it for one geometry. So for this one, of course, we can feed in multiple geometries one after another, and for each of them we will get a result. Or we can also run a design study. So that is, at this point here, FEA setup, we will connect to HyperMesh and OptiStruct. Then here, design study, that is an internal tool. We could use these variables, the design variables from the geometry, and just create different design variants if we do the geometry, if we model the geometry directly in Synera, or if we import them from a native CAD tool that is available as a connector in Synera. Okay, so this one gives us an iteration here. So we go all around and run this process a couple of times. And in the end, for both cases, importing geometry or creating geometry or changing geometry from a native CAD system, we can then also create a report or PDF in the end. So this process, more or less, will be the one we will deal with today. So we will start with the very basics and yeah, how to connect the nodes and so on, and how to create workflows in Synera. But then every example we do is more or less about this workflow, because that is the most effective we can set up at the moment for the Altair products, and the most common used, I would say. All right. So at this step, I would just go in Synera, but if we don't do the training right away, first I want to give you a quick demo how it would look like if you set this up using Synera, so you can get some inspiration, and then we will see how we learn all this. So this quick demo I have already imported, because this one import took 1 minute, so I've already imported that. Here, this relative file path relates to a location on my PC. So the import geometry imports two geometries. We have this GE bracket here. That's one geometry, and the other geometry is this was like steering like a lever, kind of a lever, cantilever for automotive. So and you can see that here, this is these surfaces have already the attributes green, and then here we have a surface that has the attribute blue, and it is the same for this GE bracket. So you can see it's a total different part. The one might be from automotive. This one is aerospace. Also, it's differently located. Total different shape. And what we want to do, first of all, we will set up the process for a very easy FEA analysis for this part. So at first, what I will do, I will filter the attributes. So this is the note to filter attributes. Doesn't do anything. I need a value. So I want the blue. So here. Okay, now this filter attributes node gives me all the surfaces that have this attribute blue. I'm lazy, so I'm copying. That's not the best practice at the end. But then I see, okay, I also need a green color. That's probably not the right green. In that case, we need this really fancy looking green here. And I also get the attributes for the fixation here. All right. Then we can make use of templates. So Synera has already pre-built templates. Let's check them out. You will find them here in the template browser. And we wanted to set up FEA. So let's use the FEA tag, filter for FEA. And I would go down, let's say simple FEA. Okay, let's use the simple FEA template and see what's behind it. Okay. So let's have a quick look. What does the template do? The template, quick FEA, feeds in a part. Okay, here we have this cantilever. Very academic, very easy. We have an element size. Then, so this is the meshing here. And at this point here, we use the internal mesher in the template. So for you as an Altair user, of course, you use, that is a solid body, you would use the solid mesh, HyperMesh. Then we go further, and a mesh is created as a part. The part is basically the mesh and the material together. In HyperMesh, you would, and this would appear in the .fem file, and in HyperMesh, you will know that as a property. So that's basically the combination of the material and the mesh. Then here we have some RBE elements there, but yeah, we'll just simplify that. Don't need RBE 2 or 3 elements. Then at this point, we can make that even slimmer, like this, for example. It's also best practice, always keep that nice and simple. So then a force is applied. So for the force should be applied later on the blue surfaces, and the fixed displacement here should be applied for all the green surfaces. Right, so force, fixed displacement, that makes a linear static mechanical load step, and then everything is fed in this construct model node. So our solid part from the beginning and our load step will be constructed as a model. That means a FEM file is written and or constructed, and here then we use the FEA solver. Of course, then also here we use the OptiStruct FEA solver. So when we put in the model here, that FEM file is created, it's going to be sent to OptiStruct, solved, and the results are coming back. The solved model will come back, and then here in the model view, we have some post-processing going on. All right, that's the simple. That's the simple template we're going to use. So now we have a different body. So we have this body here, our GE bracket. So first we want to use that as this body, and say here element size, I don't need this. I know that for this part element size of 4 might be nice, so let's use that. So meshing is performed already, and then we can use here our filter attributes geometries. So blue was the force, and green was the fixed displacement. Everything is defined. Let's see, meshing has been performed. All right. And here we also can see our model, but we don't have any RBEs. And then we can now also run the solver. I'm using this, not using Altair at the moment. We use that later, just because here on my PC that runs a bit faster now, and I'm presenting, but it would be exactly the same. So we can also do that, but I would just put that cable here, that wire into this model. It's exactly the same. So you can just, for example, when you have don't have so much Altair AUs available, you can set the workflow up using the internal solver just for the setting, and then when you select, I'm fine, and the colleagues are also done with their licenses. Now I'm also in the row. I have licenses available. Nice. Now I can use the mesher and the solver from Altair. Can be helpful sometimes. All right. Long story short, this is the FE result of that GE bracket. And now maybe you're wondering, yeah, I'll go back to this part here. So yeah, we have the same filtered geometries here. So to make it run also for the other one, I only plug in the other part, and then that's the point of Synera. So you set up the workflow. And here only the extraction of this attribute surfaces is going to be used for a parametric approach. No certain logic about the element size. Of course, this is super simple here. There's no RBEs involved. There's only one load step. That's all true. It's just a quick demonstration. So that only adds on top of that and increases complexity, but the basis is the same. So the basic approach is totally the same. So we just feed in another part and expect that the workflow should run the same. So we can see that at the moment here, the meshing is performed. It might take a little longer for that part because there are also some small surfaces inside. Let's see, it should be like 1 minute something. So we are close. All right. So meshing has been performed already. You can see that here. And you can see also that it got solved already. So just as a quick demonstration, that's the basic concept for FEA automation, what you can do with Synera. So to automate all this stuff, usually for this part, you would say it's a new part. I have to go into HyperMesh and model that. I have to go here and assign the new surfaces, or at least do that. And everything here is geometry based, so it's not node based. Just pick the geometry and then do the assignment. I think there was a question from Amit. Is it possible, Amit, that you, or see, or Praveen, could you unmute him? Mm-hmm. Oh, it seems like not. Hey, Praveen, are you there? Could you help out? sorry, at the moment I don't have these options here. I don't see. I can see the chat. Let me see participants. Okay.
Yeah, I think I can. I'm unmuted.
No.
Marvin, can you see me? Can you hear me?
I can hear you, Amit. Yes. Now I got you.
Yeah, sure. So just one question here, Marvin. Like, for example, you started with a model that is coming in, and then you establish the entire process, right? So, for example, let's suppose that maybe let's take a use case, okay? Let's suppose an air conditioner outdoor unit, where you have these copper pipes. Now there is multiple number of turns, and it's like now how it needs to be bent is something that designer would be making a lot of changes onto those designs. So let's suppose like a designer, like I have to show this tool to a designer. Then in that case of a scenario, if that needs to be integrated, is a process I understood, like no, this entire template can be done. But can this be given to a designer in such a way that he just takes a model, click on a button, and it gives him the result? Like this entire process, can it be integrated as a batch mode something into their tool so that as soon as they finish a design, they click on a button, in a background Synera opens up, it does the same, the template is already been set there, and then they basically get a result whether it is satisfying their requirement or not. So can this also be packaged as something, as a one tool, and then it can be given up? Like, is that a possibility in a batch mode, something like that?
Thanks, Amit. Yeah, that's a good question. That's totally possible. So it depends on the other tool. I give you certain examples. So at first, I would start from the easiest. We will dig into that later. But we could condense it in a way that, for example, it's still in Synera, so the designer might still open Synera directly, but then you can also, right now we have to put that into this embedded workflow. See, okay, I see the other. Yeah. So we have embedded that in this workflow, so we can still access it, but you can also block it so that it's your expert knowledge is stored here, but it's maybe on a server in the company. Everyone can use this node. Now it's only one node, but actually use this whole FEA. And the designer or the other tools that use this cannot access it. You can protect this with a password. That's option one. I would just go back, make this reverse. So then there is another option. So there's a headless mode. You can run Synera headless. That's also possible for the Altair Partner Alliance version of Synera. And you can just call the workflow. And you could also do that from another program if the program allows it. So I know that we had the partner once, and that partner was very profound in doing this automation scripts. And what they did is a automation for CATIA. So they programmed an interface between Synera and CATIA so that they can use Synera from CATIA. So the designer actually did not even have to leave their beloved environments. They can stay in CATIA, and in that case, I think it was to have a line, and from that line they created a hose, some kind of a pipe, flexible pipe. So they use that line and some diameter constraints, and then they click on a button, run CATIA in the background, and get that geometry as step back into CATIA. That's option two. What you can do, but that it requires more programming effort. But I think I don't want to highlight it too much here because it's not relevant for Altair users, but we have a different product. It's called Synera Run. It's very interesting because what I show you here, pack everything up into a workflow. Everything works kind of the same, but what you do then is that you publish that. I have that button here, so you publish to Synera Run, so you have this workflow available in a browser. So in the internet, just any browser, it's just a link you can send to your designer. They can click on the link, and then they have a nice interface in the browser, and they can work that out. But unfortunately, that is not part of the upper version. So for you, for Altair internals, I would really go for option 1 or 2. So first, making that approachable in Synera, but if they want to run that, they can also run that in batch using Synera headless. Amit, did that answer your question?
Yes, it answered the question. Thank you very much.
Perfect. All right. Very well. Then I would say I hope you have all downloaded this training material. I think if that would be super good. Downloaded also Synera. So now would be the time where we switch. So when you have the download, when you've downloaded Synera, if you have installed that, that's of course a requirement before the session. Then Praveen has sent around the training data. I hope that everyone has that open because now we really dig into the Synera basics. So that's super interesting, especially for the users of the attendees here. Can you give me a quick, maybe in the chat, can you give me a quick hint if we should wait 1-2 minutes or if we can already start? Maybe like a quick thumbs up in the chat would be good. In the meantime, I can I have also a question here. All right, yeah, it's loading. Thanks, Amit. That's good. Yeah, let's sending the training again. Yeah, that's the link from Praveen. And everyone should be like this. I've just pasted the link again to everyone. Then let's wait a couple of minutes, and in the meantime, I will try to answer the other questions. There was one from John. How the boundary conditions are applied to two different parts with same workflow process. How is it identified? John, we'll unmute you, but is the question is the question already answered with a quick demo? John, do you hear us? Okay, seems to be. Oh.
Yeah, it's not.
Okay. Yeah.
Hello.
Yeah. Okay. Is everything fine? Everything answered?
Yes.
All right. Good. Thank you. Right. Let me see. All right. Okay. There's also two other questions from Amit. So a question about assemblies. Yes, we can also deal with assemblies. So you import them and then you have different layers and then you can just filter out these attributes on the layers or different parts. That would be possible. In contact, yes. So there are also contacts available. Okay. Then I would say we get started. Please open this file, Synera Basics. And what you can see is that it's like this. The file. Let me quickly get meeting control. Okay, now I can see everything. I can control the interface. So good. Right. At first, we want to have a look at the user interface. I will here, but you could just at first listen. We will have a look at this. So when you open Synera, it appears like this. So you always have the canvas on the left side. That is this whole area here. That's where I pan all the time, where you saw me creating the workflow. And then we have the view on the right side. You already saw that in the quick demo. 97% you will work here on the canvas. And on the right side in the viewer, you will just have a visual control. There's also the option to load in some surfaces and to hard copy them onto the canvas from some designs. You can do so, but then of course break any automation. All right, so let's just start with the user interface. So we have many from other programs. So you have the file where you open recent, you save stuff. Then the edit, it's some things are available here as well, like the node browser, the template browser that you saw in action. Here, tools is important. The settings are very important because that's where you could also control custom mouse gestures. Libraries, we will get to that later. Add-ins, that is for the Altair related version of Synera, not such a big thing at the moment because all add-ins that are supported within the Altair partner alliance are already part of the installer. And then here, the license manager. Under help, it's also interesting, most interesting, the hotkeys. That's a PDF, so it gives you access to all the hotkeys, to the shortcuts. There are a lot, and as I said before, we will focus on the most important. If you found a bug, if something is not working, you have a direct connection here to report that bug. And also here, what's new in Synera, you have access to some overview pages of the last versions. And here, when you click that, you know what Synera version you're on. These things bring us all to the right, so they need a portal account. So that's very important for the new users to have a Synera portal account because then you get a newsfeed and you also see your initials here. So you have a user, you have a portal account. You can control the settings here, and for example, you can use the global search. So here, the search bar. For example, you have a question for FEA. I'm logged in now in my Synera portal account, and here this gives you access to what we use, what we need to have a look on, mostly the academy. So training material about FEA, documentation. So there are some articles, and there are also some FAQs. Here, for example, maybe you wanted to know the question Amit asked, how you could establish that contact between two parts of an FEA model. Yeah, other people also had that question before. It's already answered. That's the fastest way to get that question answered if you use Synera. That's why a portal account really makes sense. All right, let's take one level. Let's go one level lower. So here, it always starts with this new workflow. If you start Synera the very first time, you have a guided onboarding tour. That's 10 steps. It takes like 5 minutes, maybe 10. depending on how detailed you do all the steps. Don't need to do that now because we're doing similar steps together, but that should help you also to get started. When you open a new workflow, you can do that with this plus, then it will be opened always on the right to that previous workflow. Okay, so this is the main thing. Now we go in the canvas. So in the canvas, here at first we have a menu, and it's called the ribbon menu. That is a little bit more space. You can unfold it using this small arrow sign, and you can scroll through it using arrow signs on the left or on the right. And in the ribbon, I will quickly go through it. You will find all the features that are available in Synera, and they are sorted bottom to top. So we start with very basic things like a control, for example, like a toggle or the number slider you already saw when I entered the element as before. Then general imports. Already here you see also import for an X, for a general geometry, for other stuff. So that is available here as well, and the export. There's also Excel tools, very powerful because, for example, you can control all your local material data in Excel and just import them and control your workflow basically from a table. Then we go more to the right, just go through it so that you have a main idea. So that is data structures, that are specific functionalities to organize your data flow in the workflow. Then we have some math operations, reference, you need that from time to time, you need a vector or plane, or also here we have some nice design patterns that you can, some Voronoi, for example, that you can use. Then we go for curves. So here we have this create, analyze, and modify. That's a concept we have for most of the feature topics here for the areas. So section for curves. When you extrude a curve, it can be a surface section. Then we have a mesh section, but that's not an FE mesh, that's a general geometry mesh. Then we have a very powerful voxel engine that is also used commonly for topology optimizations. For example, when the part is very tricky, you can voxel everything in seconds and then run the optimization on that mesh. That is very good to get a design proposal for the start. And then some geometry features, you know, that like intersecting things, Boolean differences, but also some fancy stuff like twisting or morphing in geometry. Yeah. And then we come to the FEA section. That's of course super important for you guys. So here you have everything that you need for modeling. For example, you already saw the solid part. We can thicken a shell mesh, or like you see also the shell mesh, the solid mesh, HyperMesh connectors that connect to the Altair software. A lot of stuff here that we use for modeling. Load steps, linear static, non-linear static, buckling and modal, that and steady state heat transfer, that are the ones that are supported at the moment. All right, so I think, yeah, later on you can go through that by yourself. We don't need to do that extensively. Just remind that you can also click on the right. So here we have the solvers, the OptiStruct, optimizer settings. So a lot of optimizations are supported and so on. And then we go more into the, let's say more add-ins that are not relevant for Altair users at the moment. But here you can also find, for example, some stuff still for AM, nesting, analyzing that, machine learning, super interesting, because you can run for a model, for example, if you have a lot of data from FEA, you can store that and you could use that as training data. And when they are sufficient, then later on you don't actually need that simulation, and you can also run some machine learning stuff to get a first idea, maybe. Okay. We will explore this tool stack later, but here you find everything else that are utilities, for example, dictionaries, working with text, so on and so on. Okay, at this point, I will make a quick stop, and there were some questions from Amit. So if it's possible to include also reporting, report automation, yes, that's possible. So we find file system, also under utilities, we have the reporting. I will give you an outlook how a workflow looks like in the second half of the day. And then for the DOE, do we integrate with HyperStudy, or Synera has DOE tool itself? Yeah, we don't integrate with HyperStudy. We have that DOE tool inbuilt in Synera. Also, that we will see later. And are templates for load steps customizable for nonlinear analysis? Yes, everything is totally reusable and customizable. So if you use any template here, as I did before, you can just go there and here choose this template, and then you can swap the linear static load case with a nonlinear static. And yeah, then you need some nonlinear adjustments here and there, so maybe some stiffness values for a spring element or something like that, and you can just use that. So that's the beauty maybe of show you here. So linear static. So then here we just use the nonlinear static. If you would give it another name, maybe nonlinear, like this. Then put the same loads here. And then we of course need some nonlinear geometry or any other nonlinear data that can be input here, but it already works just inputting. No, it would be linear static because there's no nonlinear settings here. Yeah. Okay. So also like orthotropic, anisotropic material, some kind of nonlinearity could be fed in, and then you just put this this load step here instead of the other one. That's the only thing you need to do. All right. Then Pankaj asks, is there a lag in the display? I will unmute you. Can you still see my screen? Is everything visible? Or could you quickly?
Yeah, I thought earlier there was a lag while you were showing, but now I think it is fine.
Mm-hmm. Okay, thank you.
Thanks.
Okay, cool. Then move on. Let's move on. This was the ribbon menu, and here we have also these browsers. We will get to that more in detail later. So what else do we have? We have the sidebar. The sidebar is important when you set up this condensed workflow like we have before. So you can click here, and there you can give that workflow a name, a description, and so on. Control the inputs, the outputs. You also see updates. For example, there are two nodes here because the training data is built up in older versions, so that people that use Inspiring Icarus or Judicious Huracan, or two available installers in the Altair portal, that can both work with these files. But I'm on the newer version, so I could update this. But I decide now that I don't want to do that. I don't need it. And Synera itself is unitless. Yeah, just as HyperWorks, but you can use some pre-built unit systems, and then you can use this issue as well to set it up for the workflow. I think also in HyperMesh there are at least some recommendations of unit systems that could be used. As we are unitless, we usually work in this kilogram, ton, Newton, megapascal system. Yeah. All right. Then super important, I want to highlight it especially, is this one here. So this is the solution control. You also see this here in this little picture. For me, I put it in manual mode, so when I have big workflows and I open them, they do not start immediately. Per default, it's set in automatic mode. So now I have to manually click here on play. It might be that you click on this just by chance, and that means you stop the workflow. So then nothing is working, and you're wondering why you can't set up the workflow, why no data is flowing. That's why the solution is probably paused. Here you can also cancel solutions. You can see, you can zoom to all, so you can zoom to the whole file. So that's the whole file for the for the workflow here. We don't need that at the moment, but you can get a good overview. And also you can zoom to the one that is running at the moment. Yeah, and here we have some view settings, so you can have this view and you can have another view, and you can jump between. That's very nice for presentation, so you can jump on the canvas. All right, let's quickly go to the right side. So it's on the bottom you have that you used to, so different view modes. Also, this show attribute color button that makes you show highlight the attributes or hide them. And then similar as you see in the canvas, also have them to all, and so on. Different camera settings that you can undock the view as well, and full screen mode. Okay, on the canvas with in here, so we can zoom using the mouse wheel, and we can pan with the things here. With the right mouse button, you will turn or you will rotate, and when you press also Shift, then you can pan. Zoom is the same. All right. Something gets stuck. I get feedback, so I will stop share. I will share again. Okay. Sharing again. Please let me know. Please let me know if that is better. Right, good point. Switch off video. Is it time? Audio is better. That's also good. Okay. I think also here's maybe there's some interruption. I also see some, yeah, there was a kind of a interruption, I see. Yeah. Okay, very well. So that was a quick introduction to the user interface. Then let us go for, see the screen is, okay, super. Then let's go for step 2, and that's the hands-on. So now we will dig into basic workflow creation. At first, we already saw the ribbon menu, but now I want to show you a way faster method to get nodes on the canvas. So I will zoom in here so that you can also see what angle. So the menu, it's called the radio menu, and you can access this by double-clicking the canvas. If you just double-click the canvas, the ribbon menu, the radio menu will pop up. Okay, thanks Tobias. Audio is lacking again. That is very unfortunate. It's very unfortunate. Can you give me a quick info if you can hear me well or if it's still lacking? And give me please give me one moment. Okay, I changed, did some changes here, changed something. Can you hear me now better? Not steady. Yes, thank you. Okay. I'm in a different, all right, cool. Very good. Can you also see my screen? Amit, can I unmute you? Could you give me a quick feedback?
Yes, we can see.
All right, very good. Yes, perfect. Let's move on. Thank you. Thanks for the feedback. All right, so where was I? The radio menu. So when working in Synera, so the fastest way to put nodes on the canvas is the radio menu. So you double press, and then you see this type to search, and you don't have to press here or do something. When you press, you will also get there, but it's the most easiest thing is just to type. For example, what we want to do is to put the multiplication node on the canvas. So everyone, I will zoom in a bit. So again, double click, or you can also press space, Leertaste here on the keyboard. So you can press space and then type mult, for example, for multiplication, and it searches all the nodes because you saw that there are a lot of nodes, and it gives you the recommendations. And usually the best fitting is on the bottom, and then we choose this. So that's the same node I pick here as we can see in the math section. All the way to the left. Then we say operator, and here we find the multiplication. That would be also a way to grab the node. And there you can just take it, grab it, and then release it and put it on the canvas. That has the same effect. So I will do this again here for the ribbon menu. You go all the way to the left to math, operator, multiplication, grab it, and release it. Okay, but the fastest way is the ready menu. So let's have a closer look at the node. A node always has an icon that indicates visually what it's about. Can be interesting, for example, arcus, cosinus, arcosinus, you just know that already from the icon. And the name multiplication gives you also indication. Then if you hover over it with the mouse, then you also have a quick description what the node is about. For multiplication, it's simple, but there are also other nodes where it's not so trivial. Then on the top right, you have this indications here. So there are different colors. Now we have yellow, so we have warning. That's yellow is warning, and it just tells us now that for these both inputs, the node fails because there are no inputs provided. That's true because we haven't provided them. So thanks for the warning node. We can do so as well for the inputs. So hovering over the input name also gives us information what we should input here, as we also have on the output. And you can also see data in Synera always flows from left to right, always like this. So let's build our very first simple workflow. We need an input here. And we do so by, that's the fastest way. Of course, we can just, again, click the radio menu and then search for something. But let's directly use the best practice, the fastest way. We hover over the input and you see that it gets slightly bigger to indicate that here is something behind. So you can drag out the wire, and this plus sign here indicates that there is also something behind. So when you release the mouse, the radio menu opens again. And now we want to use the number slider. For me, it appears here, but you will see different things here. That's because the ready menu with the functions that are suggested adapts to the usage behavior. So adapts to what kind of nodes you usually use. And it also adapts to the location and the nodes that are around this area here that are very close. So I can choose the number slider. If it's not displayed, I can also tab number slider, so all num. And then it shows up in the bottom, and I can again quickly select it. No, of course I need to zoom out. And the number slider appears on the canvas. It's per default set to 0.5. It can be also changed by just clicking on the value. I will try to make my video again. If it's lagging, then just tell me. Then I could hide it again. All right. Then for item B, we don't want to use a number slider. We want to use something different. I pull out the cable again, release it, and then I want to use the panel. Or typing panel, and the panel will also appear. So the panel is useful for in and outputs. So first, let's just also put a panel to the output. And it's the same. Like I just drag out the wire, and I put the panel here. So nothing is happening. 0.5. I'm missing one input. So I can double click in this panel and then, for example, type in 10. And press OK. First, I see that the panel automatically resizes to the number I put in, and that's very good for static values because it's not so easy to be changed. This is more for parameters and design variables. So I have the input here with 10, and in the panel output, I can see the result 5, because 0.5 times 10, okay, Synera works. So everything is parametric. When I change the number slider, then of course the output changes accordingly. All right. Then I will just drag this a little bit to the right. I will make some space here. So we want to connect this output now to another node. So we have a small operation here, and then we want to use this, for example, as a radius for a sphere. So let's again use the ready menu, and I will type in sphere. It will come also with SP immediately. I will put the sphere on the canvas, and you can see that the sphere now appears also on the canvas at the viewer. Sorry. If it doesn't, then maybe it's not zoomed in, then you can use this this zoom to all button. Okay, so that's our sphere, and then we want to use this output as the radius, and we just drag the wire and plug it into radius. Zoom out a bit. The screen is lagging, so I'm stopping the video again. That connection is good for me. All right, but probably better like this. Okay, so we have the multiplication and we have the sphere. That is the very first workflow that you just created in Synera. And now when you change the slider, of course, the sphere also changes accordingly. Right. So let's learn about the most used shortcuts. One is the Control Q. That is for visualizing and hiding geometry, so everything that is visible in the viewer. So I can do that on the sphere. You see that when I click the sphere, it gets highlighted in blue. Also in the viewer, it gets highlighted in blue. So on both sides, it doesn't matter. When I now click Control Q or use the right click on the node and then this menu, here it says visible. If I untoggle that, the node will be invisible. That means not the node itself, but the output. That means the node appears to be gray. You see that multiplication is still whitish. This is more gray, this sphere node. If I use Control Q again, so I can toggle between, I can hide and show the output. That's very important if you have a lot of nodes, because by default they are visible. And yeah. So the other point, the other shortcut is Control E. When I press it and say Control E, it deactivates the node. You can see that it's kind of a little bit blurred and fainted. So when I change any parameters, there's no effect in the sphere. It doesn't work. That's also nice that you can disable, for example, a solver, and then do some changes in the FE setup so that the solver does not start to run all the time. So very important shortcuts: Control Q, hiding, showing, and Control E, enabling, disabling. And we'll find both by right-clicking. These are our quick tips. Also interesting. Sometimes they appear. They are event-based, so they might give you good hints. So I did that a couple of times now here using this menu, and Synera says, that's actually a faster way, so why not using this shortcut? All right, so the next step is the node help. Each node has a node help. When you go on the node, so for the sphere, it's very easy. You will find open example and show help. And when we press show help, it will open a pop-up window here where, of course, the category, some simple description, but then also the usage is described, like how is the node used. And for the sphere, it's very simple, but for example, the solid topology variable, I will do that here, is very extensive because it's way more complex. So here you can see that there's much more inside. We can see how to set it up, a lot of examples. And this help is like the manual of Synera for the nodes. It is available directly inside. So there's no additional menu. There's an online documentation. We'll get to that later, but using the node tab is the fastest way because you work in the workflow on the nodes. So you should use that directly here. Even cooler is the examples. So you can right click on the solid topology variable or the sphere, any node, say open example. Like 80% of our nodes have this extended help. And then a new workflow opens. You see that here in the menu bar, and with examples already. So for example, solid topology variable, that's design variable card in OptiStruct. For example, yeah, you want to set some typical settings for additive manufacturing, featuring overhang constraints, a certain penalty scheme, you want to add some draw constraints for casting injection molding, you can do that. So, and you also see upstream, downstream, some nodes that are usually added, like the weight compliance response for as an objective, or here the volume fraction as the constraint, typical values for performing a solid topology optimization. And the cool thing is that you can just copy that, for example, if you like that and want to use this, and you say copy, you go to your project, and then you directly copy from your help file and paste that into your project. So you can already use this whole setup here, this defined topology variable with these nodes and this OptiStruct optimizer. I think. Yeah, okay. The licenses are available. Maybe that was a connection problem from before. All right. So main key point here, the node help. Yeah, you should use that extensively. Just right-clicking on any node if you can't get further. Of course, there's also one for the sphere that looks a bit easier, and copy that to your workflow if you want these examples available. And I already mentioned that there are more shortcuts. You will find them here under help hotkeys. Okay. Then let me quickly check my timing. All right. Are there some questions so far about the very basics of this workflow creation? Right, it doesn't seem to be. Then let's move on. If so, then just simply write in the chat. Right, next thing is never start from scratch. I see that I have some, that was because of my former license loss. So never start from scratch. You already saw the templates in action, but there are more features that make us that help us that we don't have to start from on a blank canvas. So first is the node browser. So on the top left, you see the node browser. By clicking it, you have a better overview of all the nodes than even in the ribbon menu. And we can also search here as we can in the template browser. For example, I search for the polygon, and yeah, that's a simple curve. It tells me it's in the section of curves here. That's the best fit result. And I also can see the short help on the right side and access to the extended help on the right. So that's the same node help I can access from here. I can click on that, and then if you do not click any further, I see that I can place the node somewhere. I want to place it here in my area for the node. So, and yeah, that's the node browser. So if you want to search for something, like again, let's say OptiStruct, to search something for OptiStruct, it gives us some different solutions where it fits the name, but also I can use the search in and outputs. If, for example, I want to use, want to search for all nodes that have a plane at the input, I can do so. All right, then I've prepared a small workflow here on the right, and what we need to do is to connect the node simply to this curve basic container. These basic containers, they don't do anything. They just hold data. So they're just, it's a placeholder and a storage for intermediate storage for this curve here. If we want to create a curve, we need to go to the curve section and say create, and there we find the nodes for creating curves. So this basic containers you will find in every section at the end. So also here, like in curve, you will find them here. At the end, there are some basic containers. And here's the curve container. Okay. Nice. So I will hide this here. So, and yeah, here's my polygon that was just created. This little workflow, when I highlight these, so again, I just press Ctrl Q. we have the boundary surface, so that makes a surface out of it. And when I extrude the surface in a direction, for example, Z with a certain value, I get this, this little solid here. When I then turn the slider, it also adjusts the geometry. Okay, we will use that later for a quick outlook I will give you. And will come soon. So here we have one information about the wires. You can see that here this is the wire. It's the default state. When I click on it and click then right on the canvas, I can see that we have different styles. So this is default. It's gray. Then we have this faint. So you see that it's super light gray. And then also you already see that here there's nothing, but there's a little indication of a Wi-Fi here, Wi-Fi symbol. So if I use hidden, then under hidden, I can hide this wire. So and what I do when it's hidden, I can press W and all the wires appear again in the default state, but just for pressing the W, that makes me able to select it again and change the wire style back to default. That's another very very important key command here. Okay, here we see that this wire leads somewhere. So let's go and check it out. What's on the other side? I will press W, check the wire, and then with Control and using the arrow buttons on the keyboard, I can jump to the start or to the end of that wire. So when I jump to the end of that wire, I can also zoom out and see like, okay, that's just where I am now in the main file. I see that I can just jump to the end right here. So I got this license issue before, as said, probably because of a bad connection here. So I'll quickly go through that workflow and press these things. Okay. So I'm sorry about that. All right. So this is a quick outlook. You don't have to do anything here. I just wanted to highlight that to you, but I probably just run that in a different workflow later. So what I wanted to highlight to you is the parametric FEA approach. It's basically the same as what we saw before. So at this point in the demo, I will skip this because we lack a little bit of the time because of some technical issues and some questions. So I will move along, but you will find this workflow also in the Online Academy under parametric FEA. It basically does the same what we did before. So we have two different parts here, inputting them and then performing the parametric FEA. All right, I will skip this short break because we have one later.
Marvin, just 1 second. Have you taken a look at the questions in the chat? Anything unanswered?
Yes.
Okay.
No, I've taken on it, yeah. All right, so then the second thing about never start from scratch is the templates. You have seen that before. So let's just do it again once. Open the template browser that is on the top left. And here we have access, for example, you can use the tags to filter it, and you can also filter for using the search to filter. This place, maybe now I'll go in the CAD direction, and but there's a lot, so I want to check if my geometry is valid. So something with check, maybe, like, okay, there's even something for the FEA section here in casting analysis, check and repair body, element quality. Maybe let's use this or the check and repair body. That's also interesting. So let's use the check and repair body template. we will use, we say use template, insert it, and it will be inserted always in the middle of the canvas. So make sure when you have a workflow that you have a little space, but you see that it's also highlighted and selected in blue, so you can move it around. Just place it in this area where I want that to be placed. And yeah, we have a small template just placed here. We can modify it to our needs. In this case here, we have a body that is faulty. This one, a radiator cover from a motorcycle. Check body. Yeah, there's some problematic surfaces here, and then I use this repair body and assembly node to basically heal that body, fix that it's true, and got the repaired body out of it. So there's a lot more in the template section. Just explore that until this point, and see if something here fits your needs. Just use the search bar. All right, then there's a question from Amit. If CAD has a parametric variable in it, my assumption is that Synera can read it, and we can change that in some environment. Yes. Yeah. So whatever you import, and all the number sliders, all the variables are, you can just change them, so they can be changed in Synera, and you can run that also in a DOE, design of experiment, or something like this. If in case of a faulty body, can it repair it? If there's a penetration and intersection in the mesh, can it be fixed as well? Yeah, I think the mesh is definitely a tricky part. There are also some mesh options. Let's check it out. So it's, I don't know, you see that here, check and repair. Get that. It's more for the CAD environment here. For the meshes, there are some things, so we can analyze connectivities and all this kind of stuff, and we can do stuff like this, modify that, fill mesh holes, for example, or repair meshes using this repair mesh tool. However, you know that sometimes it gets really tricky when things are really disturbed. So I think there are some limitations, but also some options. So again, if you want to find out, it's just like I did, use the node browser, use the template browser to search for something. If you find an interesting node, right click, open example or show help, and then see what the example offers you. So here, for example, there are some mesh reparations going on. Can run that file as well. Removing non-manifold edges, non-manifold vertices. Yeah, so there's definitely some tools in here. Okay. Then I would say 3.3. That's the latest stage. So here is the Academy I mentioned. For that, it's required to create this portal account. And once you do, I would just quickly show you how it would look like for you. So, all right. So that's the Academy, and let me quickly masquerade as a non-admin user. So that's just here my standard user test account. So that's Marvin, but as a user, as you would see it, then you have an overview. You can select the learning path, and you can see here under Explore Trainings, you can see a lot of content for you. Important is definitely the getting started. So when you press here, you get some previous suggestions. So Also FEA, of course, when you click that, you get a nice overview here. You also see the parametric FEA that I was just about to show before, and some other interesting learning paths and courses. So just go there and explore. Under optimization, you will also find a detailed tutorial about DOE and optimization, design exploration and parametric optimization. So that's really interesting because not all of them are video tutorials. Most of them actually are workflows. So you go there and then you download the content and then you open it in Synera, and we have a lot of descriptions there you can go through, and a workflow example, a full workflow example about that different use cases. We will see some in the Outlook at the end of the session. Then online documentation, that is also a benefit if you have the portal account. So it looks like this, documentation. So here, for example, you have the what's new sections for all the versions, and then they match with the Altair Partner Alliance version. So 24.3, for example, that's the same here. For example, you wondered about the data containers. Can I create something with it, or what's inside? Then here you have a small article about it to read through. We didn't cover all the stuff that is available in Synera, but most of the most often or frequently asked and used. Then technical support. There's a support that's also accessible in the portal. So here on top you have the FAQs that I mentioned before, and also the support request. So if you have a question, then you can just go there and create a new request like this, select a type, bug report feature support, and then our support will get back to you. All right. At this point, I would do a quick recap. So what we have learned so far, that's actually the very basics. That's the very most important. So we have learned how to create a simple workflow using the radio menu, using the ribbon menu, how to access the node tab. That is very important. And then we have learned how do we not have to start from scratch. First, actually the node tab, so you can copy from there as well. But then you also, on the node level, you find inspiration in the node browser. Then in the template browser, of course, that gives you the best ideas for smaller building blocks of nodes. And then for larger workflows, you should go to the Academy, and there you have an overview of learning content for larger workflows, use cases that might fit your use case, your project. Okay. So then this is a bit annoying for me at the moment here. After the break, I will start a new session, so we don't have that problem. So then organizing and sharing your workflows. We have seen that before in this. We've seen that before when Amit's question came. Can I use batch mode, something like this? Can I condense stuff into and to make it simpler? So let's check these things out. First, here it's again a quick example. So I have this aerospace bracket here. That's a mesh, and I have that here imported. So you import the geometry by just specifying a file path. You can use the relative file path that always specifies a content that is next to your Synera file. Or you can use also the file path that is similar, but that's absolute. Okay, so that's version 1, import geometry like this. You can also internalize that. So here it's the same bracket. It's internalized into this mesh container. I will do so by just placing a mesh container on the canvas, and then I put the data inside. And then here on the data, on the basic container of the mesh, I press internalize. you see all automation would be cut off in that case. So because there no data is running, because now the data is kind of hard-coded in this basic container and stored here. Sometimes you want that, for example, in our templates or when sending data to your colleague. Okay. So I did this here just as an information. And also I did this here for another part, this brake pedal. Very interesting also here you see that this is conversion modeling. That is a mesh that has been unified with a solid body here. And Synera is capable of converging modeling. So you see that this is now a facet body. You can see that in this, is that a dotted line? Yeah, something like that. So it's gestrichelte Linie here. So you can see that, yeah, conversion modeling that is handled as a mesh, but it's actually a facet body. Why I'm telling this, just to get an intro to our next part. Automatic reconstruction of topology optimization results usually get isomesh of a topology optimization that looks, for example, like this. Sometimes not so. This is smoothed already, so sometimes it's more even rougher. So we need to smooth that. We learn more about this later or in the basic tutorials in the online academy. So what we do then is to convert that into a very nice looking quad mesh and then convert that back into a solid. So I just feed this in here to let this small workflow run that I've already set up here. And let's check it out. Convert quad mesh. We want to highlight this. Yeah, this looks much nicer, this quad mesh thing. Okay, yeah, here some artifacts. This is not so good. Probably needs to be tweaked a bit. Nevertheless, it is sufficient enough for our small example here. We feed it to our mesh to solid node, and that is running. So you see this progress bar. So that's indicating the progress of the node. All right. So when this is run through, right now it has. That's good. So we have we feed that here again in the basic this basic container. That's the automatic reconstruction of that mesh that we have before as a step file, can be IGES or whatever. In this case, I want to export it as a step, so I provide also relative file path here within the file name, and then here I have the export step node that exports the step now to my location. Here then in the output I see, okay, now it's successful. As a quick recap, always use the panel when you go through your workflow and check the data structure. Now it's not important because we only have one item here. We can also hover over it, but it's very easy, a very good, easy way to better see what is inside. Okay, we disable that just to show you what this workflow is capable of doing. What is actually the focus of this topic, organize and share your workflows. When you have that, you can condense that. So now you see a wire is routed in, so we have input data, and a wire is routed out, we have output data. So we can select everything, and selecting everything, I always do that from right to left. So I draw my rectangle from right to left, so you see that everything that is touched by the rectangle is selected. That's very fast. I can do also from top left to bottom right, but then you see only what is inside this rectangle is selected. That's the difference. Also practical, but I would say 95% I use just this right angle selection. So we select that, and then I can right click on the canvas and do what I did in this quick demo before when I showcased that to Amit, create node from selection. And here I have different functions. I can say embed into this workflow or save as linked workflow. It is the same on the canvas. The one embed into this workflow means that the workflow will be embedded into this workflow. No other file is created. And when I send this Synera file, this embedded workflow is already part of it. When I save it as linked workflow, then a new workflow is created and I need to save it before. Yeah, it needs to be saved, and then this is like master and slave. It's not a good expression, but commonly known, or parent and child, or whatever. You know that. You get the point. An included workflow. So for this, it's just a quick insight into this topic. Definitely there's more to talk about, but we would just use embed into this workflow. And then you see everything is condensed in one simple node. Very good for presentations, very good if you have a lot of nodes on the canvas, and you can still access it. And I will zoom in. So when you hover over the icon, you see that something is inside. So we can click on the icon, and then here we see our workflow, and we see that directly input and outputs are defined. And that has been automatically done because when I look at the workflow, back to Synera. When I look at the workflow, so we just make Control and Z. That's how you can get back. As usual, data is already fed in here in the beginning and at the end. So I can also take this and do the same step again. Create node from selection, embed into this workflow. But then you see there's no input and output available, and it also shows as a warning. So I can go inside and then define the inputs here. So I can do that using the sidebar. So I can add input and then say, my mesh should be the input. Zack, it's defined here. Or I can also use that by right-clicking this basic container and then setting it, defining it, or registering it as an output in this case. I can save that file and go back to the parent. And you see that now I have my inputs, mesh, and solid body. That's the automatic mesh conversion to a solid body by just entering that mesh. So there are different ways. I can also just define the input and outputs here and then convert it. That doesn't make a difference. Okay, so now shortly before the break, I want to use the aerospace bracket because that's the one we used. I want to use the brake pedal. So in best case, this workflow is robust and works for both cases. So let's see how it performs for the brake pedal. If you deal with the automatic topology optimization result reconstruction, then you might run into several issues of it's not really robust. It's very bad mesh, for example, and there are certain cleanup options and ways, and they are also available as template. So just check out the templates. You will find at least 4 templates only about topology reconstruction. In this case, you see that it succeeded, and this workflow seems to be fine for both of the inputs. All right. Before the break, there's one question for Amit and also the others. We can take that time now to ask some questions. I have some things ahead, so I will reload the file not to have these annoying issues. I will suggest that we continue after the break. It's a quick overlook about the tool stack that is fast, and then the data structures might be a bit condensed, but you also have the files, and these 2 examples are also well equipped with descriptions. So that might be also a nice job to go through yourself while having the theoretical introduction from me afterwards. We have that time, I guess. Okay, then I have one question here. Let's assume that after one task there is something that has been failed. Is there a way to debug it? How much information I will have to point with the issue? All right, debugging. Yeah, debugging is very important. That's true. So we can better see that in a larger workflow. But let's assume, let's just check out this thing. I think I can answer that quickly before the break in 2 minutes. There are certain features. So first of all, face. Let me I'll just do a silly thing here. Let me see what it does. Probably just might also probably just result in some long calculation. No, nice. Okay, so we have created an error. Of course, it's not possible to to condense this mesh into 2 faces. So we have a problem here. That's the first thing. So looking in your workflow, you will see these red nodes. When they are red, they have an error here. So first thing you do is reading the error. Only closed manifold meshes can be used to create subdivision models. That means something must be wrong with the input. It's not possible. Mesh Sorter cannot handle it. So that's your first indication. Let's look upstream. So here might be a problem. So I'll just highlight it and see, oh, yay, that doesn't look good. Yes. Then I check my inputs. What's wrong here with the inputs? And that's usually the first thing in debugging. I move my way upwards. Then there are other things. So for example, the validate node. See, the validate gets some data here, the body, and say, for example, the condition. Let me quickly might be that. So when the condition null is in there, I might get that message. Thing like this. Oh, I get this. All right. Okay. Now I created so okay. Then I need this one here. For example, the null tests. I say true. Also there are certain. You see that there are certain options here that they can test if that is true or not. That's the developer mode. You can also enter that. Can use something like that. So in this case, okay, it's true, but we actually want it to be false, of course. Yeah, something like this. So we can build some stuff up like this, and then in the end get the data here, validate that error message. Yeah. Okay. I hope you got the point. Right. Okay. Then let's see. Maybe I will unmute you so you can ask a in case HyperMesh fails, and yes.
Yeah. So Marvin, just one thing, like for example, when you are calling the HyperMesh in the background, now let's suppose that the HyperMesh has failed somewhere and it is giving some kind of an error. Now that error as a callback, can it be reflected here in the Synera environment so that I understand, even though knowing that okay, HyperMesh has failed, but I also understand okay that maybe I wanted to create a 3D mesh as an enclosed volume, but the volume was not enclosed. So that kind of a callback functionality can that be integrated here as well, so that it's for the debugging, it's more useful there.
Yeah. So here, let me check my license. Something is wrong with my here. Right. Maybe a connection problem to the HyperWorks stuff, but okay. So usually when I have the solid mesh or the shell mesh, then I also have this infos here, and they also give me some infos regarding the debugging of that mesh, so they can indicate. And also for OptiStruct, they also give me the OptiStruct error, so I can take that and Google that, go to the Altair help. That would be also then my suggestion. So to take this, we've covered some stuff, but then go with this error codes to the Altair manual and search for it, and there's much more information than how to get over the errors, because then it might be in HyperMesh or OptiStruct error, so we need to understand HyperMesh and OptiStruct in order to solve it.
Got it.
Okay.
Yeah, understood, Marvin. Thank you very much.
Okay, thank you. Thanks, Amit. Then I would say we have 11:07, so it was supposed to be a 15-minute break. Is it okay for you if we continue 11:20? So it's like 30 minutes. Praveen, from your side, is that fine?
Yeah, it's fine for me. It's just up to the participants. Yeah, I think we can give. I think in India it's 2:37. So I think, do you want to resume at 3? So around 20 minutes. So 20 minutes from now we can restart.
20 minutes? Okay.
Yeah. Okay. Fine. So I will pause the recording here and we'll resume in 20 minutes. Yeah.
All right. Thank you, Praveen. Okay, I hope you had a good recovery in the short break. I will start with the video. Again, please let me know in the chat as before, in case there are any connection issues. It should be much better now. Right, I will share my screen. The chat again. I also understood that system. All right, thank you. Confirmation screen can be seen. In that case, let's start. So we were at this point, step 4, organize and share your workflows. We have understood, first of all, how to import some geometries using the import geometry. That's the basic import node. And then we have understood that while registering such a complex of nodes, so such a building block of inputs and outputs, we can select that and save that as a node. If we choose as a custom node, if we choose linked workflow, then it will ask me where to save it. So in that case, I will just use this embed into this workflow, and then we have that section here. You can do that with the embedded workflow, but also with a workflow like this. So you can select that, and then also you see here save selection as template. That is very, very helpful, especially in a team or in a company where you all have access to the same file locations. You can already spoil, or I will spoil that. You can already see that here. Helper functions, low-code labs. So there are a lot of libraries I've set up. My library is available for all of you, but some of them, like this QA stuff here, that is shared within our whole company, and we use that to run automatic tests on the workflows. So there are linked workflows saved, and they are used by everyone in the company. That are small templates that can be used to validate and test workflows. So this way, our QA engineer only has to maintain one workflow, and it can be shared. And if changes need to be made in this one file, some tolerance thresholds, whatever, then it can be done in a single source. It's very interesting. It can be saved in the libraries. So here under tools, you have the libraries, and you can see that I can, for example, save this workflow in my library. Here I have a lot of useful tools that I use that I like to use, for example, and just little helper workflows. I save them here for me so I can use them all the time. And when I do so, for example, log images, they are also accessible in the search. For example, here I use I search for log images, and once I've saved this workflow as a template in a library, then I can use it and call it from here, from this library. And as said, if it's a shared library, then everyone in the company could have access to these little helper files. That is very powerful. And this whole topic of libraries, yeah, now it's not the main focus, but it's very, very interesting, very powerful. Please check out this little video. It's around about 10 minutes or something from a release webinar where I present that based on this perspective of a CAD engineer and an FEA engineer. We don't need to work this through here. We have the video, so please check it out yourself afterwards. And the whole topic of Synera Run, I would not cover that today because it's anyway not available in that installer, but that's only the little glimpse here, how the workflow, in this case a battery pack calculator, can be shared and made public in a browser. So having the inputs, a viewer and outputs, but no workflow access at all. The workflow is under the hood. So with Altair installer, you can achieve similar things running Synera in headless and then supplying that, or by setting up the workflow in Synera. So a CAD engineer still needs to open Synera, but then you can make it very simplified and yeah, break everything down and pack everything in this condensed workflows here. Okay. So if you have more questions to that, you can definitely reach out to me and check out also the online academy. There we have some content for this. But then let's move on. So exploring the tool set, what else do we have here? It's just a very quick overview. So you already have seen the slider, the panel. There's a selection. The select node has like option A, option B. So this could be design A, design B. We have certain values here, 1 and 0 and 1. And then we, for example, use the stream filter. We do that later in some workflows, and feed in one geometry here and one geometry there, and then here you can select between the two. Boolean toggle buttons can be also used because some of the nodes have these toggle buttons on the surface, and you can use them as well to be input in, for example, a design of experiments. Drop-down menus, yeah, please explore that. You can see that a lot also for advanced nodes like the solid topology variable or the OptiStruct optimizer. There are a lot of the dropouts, the mesher as well, because they're very heavy tools, very powerful tools. You have a lot of options. Okay, then for transparency and documentation, there's also a whiteboard. Right, it's here. So I'm sorry. So we have this viewer here. So in certain steps of the workflow, you can attach that and just put a geometry there. For example, we just had this sphere example. Because we can see it in the viewer, but then maybe in the workflow we move along, it's not visible anymore, but you can still have that. You can still have that visible here in the viewer and have a look at your part while you're actually doing something else. And when the workflow runs, you can still check it. You can check all the steps in the workflows visually without having them actually visible in the viewer. Images, so you can load in images. You can also just drag and drop an image, put it here, as I did with these images right here, or like everything. Every arrow here is an image, so you can just drag and drop it. And there's actually a whiteboard. So this whiteboard panel that opens, and there you can, do things like in Miro if you want to use in draw processes. Okay, some other things available, not all in that version here, but now in the new installer we have the Run CAD connectors available, at least, and not the CATIA one because that's not supplied by us. But Run NX is there, Run Creo is there, Run SolidWorks, Run Solid Edge, so a direct connection to native CAD is already there. You can use automatic report creation to PDF. We'll dig into this later. And you can still do, if something is missing in our tool set, you can still use scripts if you use the scripting and you have something that you don't want to miss in your optimization process, you can still include that script in your process. And also, yeah, some web request tools, everything that is accessible, every software as a service, and a cloud-based tool that is accessible via API, you can access that also with this web request. One simple but very cool example is that you might have a design study and then you have like, I don't know, 30 different designs, and all of these designs you want to perform a topology optimization and then in the end want to compare that. So that would be just one workflow, but it runs 30 times. And as it runs 30 times, so 30 FE setup generations, 30 topology optimizations, 30 automatic reconstructions of the topology optimization results. So that might take a while. So you can, for example, have a web request and send yourself an email afterwards. So let that run through, and if an error occurs, you will get an email warning you that there's an error. Please check it out. If everything is run successfully, you can send yourself an email and just wait for the workflow. You don't have to actively go there and check if that has run through. You can, you can turn that around and be informed. All right, so then let's hop to the data structures. As said, there are certain examples here. So Tobias, it is also interesting for you to, yeah, Tobias still here, very nice. So now it gets interesting about the data structures. Only the basics, but yeah, let's dive into it. So what are the data structures? You will find them first of all in the ribbon menu. Let's go all the way to the left. So we have here with data, and then you have data structures. So there's list entries, and that's the first question. What are list entries? So let's dig into it. So let's start with the list. First of all, you see sometimes in the workflows there's a cable or a wire that is just solid. So it's a continuous wire, and then there are wires that have this dotted, the dashed dotted line. So a straight, or not straight, but a continuous wire indicates that only one data point or one piece of data, here we call it item, is transported or transferred through that wire. If you have more than one, so here, for example, yeah, you see that in the end of the wire, it's only one leaf, let's say. Here, this data has more leaves, so more data. It's a list of data that is transported here. So that we can see here, like this is a list, and then a tree that will come in the next step is this dashed line. And when nothing is transported, it's empty. So I can quickly copy this data, and you see that this symbol here, again, we had that once very briefly, indicates that there's internalized data inside. You see here that it's a text called leaf. So I will clear this data, connect this wire, and you see that this is this empty wire, so nothing is in there. Okay. One item, multiple items. That's the first difference of that's an item. Here's a list of items. When we see that here, and we look at our small indication on the left, let's check this out. So data structure, that's a bit dry topic, I would say, but also very powerful, and many questions occur here. So we see here, let's look at the tree. We have this root. The root has that path 0, and then we have items or different leaves on that root. 0, 1, and 2. That's how we call it and calculate it in Synera. So we always start the items with 0. Here you see that is the root 0, so this one root here. If it's a single list or single item, is always only one root, and here only one item that here that it's called leaf, and it's under item 0. So when we have a list of things, list of data, here still the root is 0, but then we have multiple data here, and they are on the item 0, 1, and 2. So that's how the data is now managed. If I want this leaf here, I need to pull out the index 1. So I can quickly do that. Very commonly used node, this list item takes the list, and then we use the index. So the index now, I want to create a slider from 1 to, no, from 0 to 2. Also a quick hack here. I can type that in and then press, a number slider will be created with these values here. All right, so that's this leaf here. 1 is the same leaf. This should be called leaf 1, leaf 2, leaf 3, or something like that. And that's the third one. So it's all the different leaves here, but from the index 0, 1, and 2. This way I can run through a list. We will see this also later. Okay, so what can we do with this? Here I have a very simple example. I have a circle here, and the circle is extruded in Z direction with a certain value. Here it's in Z direction with the value 1. Okay, that's a very simple workflow. Here, and the circle is the radius 1. Here I have the same workflow, so I just copied that whole workflow here. We'll visualize that, and it's basically the same. You see that the extrusion factor here is the same, the height is exactly the same, only the radius is different. It's the second one. So then we have a third one. Okay, this third one here, it has a different radius, but also a different extrusion height. And we have a fourth one, and that's the same. Different radius, different factor of the extrusion height. So let's focus on the first two, because we can see this is what I set up here, and now I have it's exactly the same here until there, because the direction the extrusion factor is the same, only the radius is different, and that's a very good indicator to use lists. So let's go. So the goal is that we don't want this copying things in Synera. We don't like copying. We don't want to do repetitive tasks. We don't like to copy that. Only copy that, use it in another workflow. But in a workflow, it's very advised to use data structures to slim down your process. You make it not only visibly slimmer, but each node requires a disk space. So you will blow up your workflow, but you don't have to do that. You can, like, this node this whole workflow can be run multiple times. That's not a loop, it's data structures. We have also loops like for and while loops, but we don't do that here. We use data structures. It's much more effective. So here you see we come from this to that. See that this is exactly the same here. So we just copy this here all over, and instead of using that everything here 2 times, I use a list here, and I created the list using this merge node. So merging has nothing to do with merging geometries or meshes. This is pure data structure. I have one data item here, one data item here. So that's my 1, that's my 2. And then you can check out the data structure here with the panel. Now we have created a list. We have the root 0, and then we have the items 1 and 2 at the index 0 and 1. It's a lot of like, what's the item, what's the index, but yeah, I think I messed this up in the first place. But this is the index. These are the items. So root is 0. It always starts at 0. So here the index 0 has this item 1, and the index 1 has this item 2. So instead of feeding in just one radius, I can also do that here. Let me just do that. Get rid of the group. So I'm just feeding in only one input, and now I use this list here. I'm feeding in 2. I have nothing, I've done no changes in that workflow. I've only changed the input values. 2, 1, and both of them. All right, so that's the merge component, the merge node. With the merge node, we can create these lists, and we can also add and remove items. We can zoom in, and there we see I can actually get rid of this input. I can put more inputs in between, and so on. So I like it this way as it was before. Okay, so we could condense these two things, make it slimmer, and by using lists. Now let's go further. So because we haven't tackled these two here, because they change not only in the radius, but also they change in the factor. So again, here we copy. That's simple, but also lazy for this. Yeah, okay, we can do that, but it gets quite messy when you deal with a lot of data. So that brings us to trees. So now we have to use trees, but it was already fine. So we could slim that down, like erase at least this this quarter of the workflow. So what are trees? Trees are the dashed lines, and for the tree now we see that we have multiple lists under each other, and we can define a list with this root. Before it didn't play a role because the root was always 0. It's also always the 0, and then you have the items and the indices. But now we have different roots. So we have root 0, 1, and 2, and each of these roots has some items. Each of these roots starts always with 0. Again, starts as a leaf here with 0 and 1. Then this root, or this tree branch, what we can call that, this tree branch has one leaf at 0, and this tree branch has one with 0, 2. We see that also here. So tree branch 0 has 2 leaves, and 1 and 2 have the others. All right, both always starts with 0 and then adds on. Okay, so what we do, we use stack. Stack creates a list, creates a tree. I'm sorry. So we use merge to create the list and stack to create the tree. So still we have this first list here, because we still want the radius 1 and 2 to be performed with one direction, but then for the other ones we have single directions. So that means 1 by 1. And if we have this, if you know this kind of methodology that you have one with another one and that goes together, that is an indication to use trees. All right. So when we look at our example here, we see in the end 3 colors. So we have this purple color, this turquoise or bright blue, and then the dark blue. So that's how many tree branches we need to create, because they can be tackled together, and then these need a single tree. That's how we do it, and it's a similar node as merge, the stacking, but now if we compare that with the panel, we see there's a big difference. Right, so dashed line, dotted line, then here we have the tree, and that tree, so we do 2 stacks. That tree here goes together with the purple one. So this extrusion direction 1 could be combined with both of the radii 1 and 2. And then we have the extrusion direction, the extrusion factor 2, that is only for this radius here, and so on. So the dark blue is only for the 4. So these 3 and these 3, and yeah, just goes one by one. So input 0 gets to input 1 and so on. Okay, so when we highlight this, you see the exact same result of this workflow as when we highlight all of this. So that's the exact same. Do we have questions to this topic? Because that is probably especially for CAD users and non-programmers, the most unintuitive. Maybe you can write in the chat. Okay, so then I would say I would like to give this as a homework also to you. What we did here in the theory, it's exactly the same basically as exactly the same for this one here. You can just go through. So just to have a quick overview what we do here, to have an understanding how this could look like in a process. So here's a CAD related example. So this is the tree connector here. Creates this tree structure. And we want to do something like this, a pattern of 3 of these connectors. So we can do it differently. First of all, so we have these 2 circles, and it's created from one point, like a root point, and then some target points, and there's this structure here created. So you can see that here. So it's in this plane here. But we want to do 3. So first thing we can do is to create 3 of these structures. Just like this. Easy, also easy to follow, but you can see it's very, it's not really parametrically. So also this list here, so it's a lot of dragging wires and a lot of separating stuff, all the root points, target points, and then point out. So it's not really, it's not really flexible. Using trees is already nice, so you can understand. But here, again, it's like each target point, each root point has certain target points, and that is a very good indication that you need to use trees. So when you just look at this workflow, and this is much more straightforward, much more slimmer, and this here is not copied, but only used once. So here you achieve the same result, and the only thing that was done here is that here we have some certain root points. They are on 3 branches, and on each branch we have multiple target points. So it takes like the first root point and combines that with the first set of target points. Second root point combines them with the second set of target points, and so on. The only thing you need to do is to take care of the data structure and the tree path. So here we use 0, 0, 0, 1, 0, 2. That's just the structure. And for the target points also 0, 0, 0, 1, 0, 2. And then you have the items. So if you take care of that, then you can achieve the same thing, but much more effective and faster. Nice. There's some practical examples here. One is also related for RBEs, for RBE creation. So that is also pretty cool to use in some FE setups, and very commonly. So you can have a look at this as well. At this point, we would shift. So we are done with the Synera basics, and then let me look at my agenda. The next thing would be the connected engineering. So for that, please open, say here, correct file. Oh yes, it is, but that is a solution file. I don't want a solution. We want to do that together. So just use the connected engineering using run CAD connectors. We can click along a few parts, and then I give you an introduction to the main goal of this workflow. So when you open the file, it looks like this. So again, in each of these steps, we need to do something. So now this workflow imports a CAD geometry that looks like this. So we import a design, very basic design of this this mounting or bearing, and then we will create a FEA setup. We will do topology optimization, and we will do an automatic reconstruction of that. But as you can already see with some variants, there's also a design of experiment involved with different, having different design variants and calculating these design variants up front. So in the end, we end up with this. Here it's only 3. You could also then at home add more design variants. So let's go through it. At first, I don't know, who is using which CAD program at the moment. So here in that file, that is soon also available on the Online Academy, but you already have it. We have space for Run CATIA that you cannot use, but you can use Run NX. Here you could also set Run Creo or anything else, but we have provided already the input data with the Run NX. So let's just put this node on the canvas, run, and just type Run NX, so I only have this. It's like this, so I have an X installed. And then you can connect it to the relative file path that leads to a file that we have designed in NX. And in what you need to do in the native CAD is then to publish the design parameter. That is a bit different for each of the CAD programs, but basically it's all the time the same. So you set up a parametric CAD design, and that is controlled in the native CAD program already by, like in a nice structure, by adding equations, design equations, and some parameters. So you have design parameters in that native CAD, and they need to be published. So when we do it, it runs a bit longer. That also for those who have not access to NX, we're using a different CAD program or just don't have the access, we have supplied the whole design of that bearing also inside Synera. And the default, because we don't know what the user has, also you can see that in this purple group here. So these are linked to the DOE. So I'm just highlighting you. I will just explain you how we do that here, but then we run the DOE, or we look at the workflow using the internal version. It also runs a bit faster because I don't have to open NX every time. Let's do it for the first time here. So this is now the geometry that directly comes from NX. It was designed in NX, and I'm only inputting it here. I'm loading it, and now I want to change it. So first of all, I have some options here. I have some design variables here that, yeah, maybe I have a bit much more complex design than this one, but I only want the ones that I published with the name Synera that I want to change in Synera. So first of all, I can clean this up. Yeah, using this pattern input. So these inputs here will disappear. Then also there's this attached to the process button. That means if you already have an instance open, maybe with a part, you can say, yes, attached to process. So that instance of an X will be attached to Synera, and because per default a new instance will be open. So if you want to attach exactly that file that is already open in an instance, you can do that. I don't have an X open at the moment. So here, now I will connect all these sliders. So for this, I don't want that to run all the time. You have learned that in the beginning. So just connect, I will just disable that and then connect everything. So we have the width, whole diameter, it's like here, inner diameter is there, bearing case height. Oh, anchor side, and that's the plate height. Plate height is here. All right, something we could have sorted that a bit better. Bearing case wall thickness. Here. So then we're gonna run that again. And by playing around with this with the sliders, now we can do some changes. Probably also, let's see when it's imported, but probably also some of the design parameters have changed already. Otherwise, plate holder, what's a good indication? Bearing case height, maybe like this. So here now I could also use the pause button. So I want to make the height a bit higher, and bearing case wall thickness also want to do that higher, and the inner diameter should be a bit smaller. Let's see. Now this is about the robustness of the model in an X, right? Not in Synera, so because it connects to an X. So the designer who sets it up, of course, needs to make sure that when we want to run things in Synera and automate the CAD, that all these values are also applicable and the model can be built up, that the model is robust. All right. I'll stop and reshare my screen. There was a request for Can you see my screen again?
Yeah, I can see.
Okay. Yes. All right. Okay. I hope that you got that on audio, and now we can see also. So we linked all the num sliders, all the parameters to our run X node, and I've just changed a couple of sliders, and have a smaller casing now, a thicker one, but a bit higher. So I've basically changed my design a little bit. Okay. So you find this also, find this in the current installer within the JJ. So in the 24.03 Judicious Eurocan version that you can download from the Altair portal. That's basically the import of native CAD and the connection. So whatever you do will be changed in an X. So you don't have a second model or something like this, or not a step, but you basically really change the model that is in an X available. But same would be for SolidWorks or Creo that are also available. For this workflow, as I said before, I connected everything to my internal model because it runs much faster. It was just 1.7 seconds to create that model. So let's move on in the workflow. This step, you already know that. So the file has some attributes. In this case, 3 colors. For us, it's important to have, again, blue and green for fixed displacement and for loads. So we use filter attributes. And here you can see data structures directly. So I didn't copy that in the demo I gave you in the very beginning. Before noon, I copied this node. No, I didn't copy. I just used the stack and put in these colors. That means the filter attribute node runs 3 times and gives out the results also in the same data structure on these trees. I use explode tree to get access to the single branches, and then I have my fixation and my load geometries separately from each other. So that's the most effective way. Also, how Void did it when we remember our target workflow for today. They applied also Void, not Void. They applied also these color attributes. Okay, now you can click along. So here we now create a FEA simulation. We want to evaluate. We want to get some responses and evaluate these responses from the setup, and then run a design exploration. So here we have the FEA simulation, and you see that this is also a custom node. So we can go inside and see what's in there. It's again the solid part. That's like the property asset. Then we will construct some RBE elements. We have some boundary conditions, construct the model, and calculate it. So I will not dig into that, but what we want to do is to define some force and some moment. So here you see also for the challenge that's about to do, like in the homework, you see also some descriptions here. So for the force, we need a force in Z direction. And if you have this in mind, then you can already click the radial menu and maybe just type in Z and see what comes up. Then, okay, we have a unit Z here. That's nice because we can set up a vector in Z and a force with minus 10,000. So also here we can just open the radial menu and type in minus 10,000, and then you see where should this minus 10,000 go? Should it be a number slider or a panel? Let's just choose the number slider. Then we can connect it. All right. So this is the first one. So unit Z goes into the force, and then also we need a moment in Y and in Z direction. So for this, okay, we can do different approaches. If you want to learn more approaches or want to check it out later, we also supply the solution here in this custom, so you can look into it if you don't find the solution yourself. But here I would go for like constructing a vector. So I would type in just construct vector, and then I have all the coordinates available for this vector. Yeah, so x remains 0. So I could type, for example, the 0 and then use the panel. I don't want that to be changed. And the other values, this minus 90,000 and minus 150,000, these are also number sliders for me. And I've constructed this vector. Okay, this goes into the moment. FEA runs. Let's see, and the model view, okay. The model view shows, okay, the FEA has run through with this moment and this force applied now in the center here of that RBE3 element, deformable connector spider, and we can move along. So here for the stress response, these are part of this design exploration. That is a powerful tool, and I will first give you a quick insight here. So it consists of a parameter setup, and that has this width and radius of the cylinder as design parameters. Those were highlighted in the beginning with this purple edge. Then we have the mass response and the stress response. For this, we need this stress response nodes here. They are already set. But what we haven't set is the definition, so the value. All right. So we need to evaluate our solved model. Solved model is here. We need our loads and our mass that are already supplied. And for this, we also have here what we want to use. So we want to have this response here, the maximum von Mises response. So it gets the whole model and it gets this load step here. It's the first response. And then for the mass, we use, the mass we already have. So then here it's in ton. So we want to make it a bit easier, available as in kilogram, just for us to know, because I said it's unitless usually. So we can use the multiplication. And then here I want to create a panel with 1,000. And yeah, that's my result in kilogram. Add this to the mass response of the model. So the mass is directly coming out of our model. So I can use it directly. Okay, the response, of course, you see, evaluate response, of course, we need. Evaluate results, yeah. This response, this model, and then here I have all the values of all the elements, but here I also have like the maximum value, and that's the one I want to use for the stress response. Okay. Now this has been set up. So the second node after the parameter setup is the design exploration. And here now it's easy because I've already set this up. So I've just added designs here. You can use that, do that with the plus buttons. And then per default is 100, but you can also use like 10. I just added 3 because the topology optimization is running. So I won't do that now because it takes some time. Even though it's simple and just I think 8 minutes or 15 or something, but we don't have that time now to run, like to wait for 15 minutes 3 times. So I already set this up here and let that run before. What you can do now is that you can reset designs, but you can apply a design. So imagine that you have an optimization and certain optimizations in the end, and then you want to choose the lightest design or a particular variant, for example, and then you can set this design to your workflow, and that would be your final design. And yeah, click create and evaluate. I did that already, and what it does then is that we run the whole process, like in this case 3 times with the different variables with the different values, and they are changed. They are changed here. So we also feed that into our topology optimization. So that's also this this node here. I have, as I said, I have disabled that, but still approachable here. So we have a solid topology variable set up with some commonly used settings for the element sizes. And here now we run a mass response objective to minimize the mass, and that usually comes together with a stress constraint. We could also add deformation constraint. We could also add load cases like eigenfrequency responses and set an upper bound or lower bound for certain frequencies. That would be also possible. And then here we run the optimization using the OptiStruct optimizer. Yeah. Some settings here, constraint objectives. Yeah, I think I won't go into super detail now to this, but that's how it's set up. So what I did here afterwards, so for each iteration, you will get a soft model. So that's how the soft model looks. It's just a model we imported, or here it's internalized because presentation reasons, or if you lack of some licenses. But yeah, you will feed that into the result isomesh. So that is now would be in hyper view, I guess. So here you would have the result with the des.3D, and that result is evaluated. So I can change now the ISO value here as you used to in HyperView. Use the standard of 0.3, and now I want to do the automatic reconstruction. So before we do that, we prepare this a bit. For example, sometimes you know that after OptiStruct has run through, there might be like little islands of meshes that are flying around here and there. So we, of course, they are not part of our main model. In this case, not. The mesh is fine. Mesh looks good. But in case they are there, we could split these disjoint meshes. And what I do here is just I calculate the area of all the meshes, and of course, our main mesh has the largest area. is the largest volume. So we sort by the volume and then filter out everything and only keep the largest volume or largest area mesh. We do a quick smoothing. So you see that is slightly smoothed. We only do that because it might be easier for the next step. All right, so then topology reconstruction. You also know that from before. It is similar in this particular case, but here it might be more complicated depending on our design variant. So we want to choose a more robust method. Here we choose a voxel approach as set. So voxeling is super easy because you can simply voxel everything. Will always work. Voxeling, then I do kind of like a smoothing here. So I want to give it a bit more headroom. So I add one layer more of the voxels. I smooth everything again here. And this is a very good basis for our quad mesher as you have seen before. So that's our nice quad mesh. Then again, I have that robustness thing here, filtering to make sure I only have the main mesh, and then the mesh to solid, which gives me the solid. But it's not like everything is smooth. It's not finally. It's not our final model. We do some Boolean operations here with the non-designed spaces in the end to get our union here. We can even remove the attributes if we don't need them further. Okay. Well, that's the end of that workflow. So when we run that through, I put this visualization in the end. So 3 different models have been created here, preferably then also using that native CAD connector, have been optimized, have been automatically reconstructed, and now you have a design variant. Okay. Let's look at the time. So I hope you could move along a little bit, click along. Then I will quickly introduce you to the homework. There's something that you can do if you want to level up your skills. So let me quickly open that. Only to showcase. So you will find that challenge, FEA design and exploration in your training data. And you see that here are the gaps, and it's a similar description as we did before. So yeah, what is the goal of this session is that you should create a solid I-beam and then use a template that's similar that I did before. Actually, it's the same template. So for the simple FEA, that should make you familiar working with templates. You need to do some workflow creation here. You can check out the logics and understand that by going through and adding panels to the outputs. Then here is the space for the template. You need to add that FEA template and adapt it so that it fits your needs. And in the end, if you achieve to do that, then there's also already here this result extraction. There's already a suggestion of learning material to run the design optimization or the design study on this part. So then we have parametric I-beam that is parametrically, you can, it's up to you. You can tweak it the way you want, the width, the height, the length, and then analyze it and have certain design variants at the end. Okay. At this point, agenda-wise, it would be good to go into some Outlook workflows. So let me show you some workflows, but we have time until 12:45, I guess. Yeah. All right. Good. Then what we haven't covered is reporting and some more advanced workflows, advanced OptiStruct and HyperMesh functionalities that you can use. So let's dig into that. Let's start with the first one, something totally out of topic, what you can do elsewise with Synera. So I've showcased some of the patterns in the very beginning. For example, yeah, this is this very simplified example of the car door here. Just assume you have a design space here, and in that design space, we want to stiffen this surface here, but with CAD stiffening ribs based on shell models, so surface state design. At first, we have a simple FEA of that door, so everything here is fixed. You can see that in these little triangles, and then a simple force is applied here in the middle. Yeah. So for this, we can turn this stress distribution into a field. The fields are also available. Let me see. Under the math section here, fields. So there are point fields, local fields, global fields. That's the whole topic for itself. Just to quickly want to highlight what you can do. So you turn the stress distribution, you normalize that, and that in that sense here, then you turn that into a field. Highlight this, so you can see that in the area of the load introduction, we have these red field values, and all the other areas we have blue field values. All right, and then we have, based on that, we do a point distribution. So we want the ribs later on to be denser in the area where we have larger stresses, and the ribs also to be higher. So we do that with this little logic here, adding a point distribution and then creating a Voronoi 2D pattern in that door, in that area here that is already projected on the door. Then there's a little logic also for getting these ruled surfaces, so for our ribs. And in the end, we end up with something like that. So when I display my stress distribution again, we see that in this area where the load is introduced, I have way finer rib cells, smaller rib cell diameters, and they are also higher in that area. Or they have this, at least there's this bump here. Right. So this is a very good example how you can combine our internal CAD tools and mechanical stiffening functionalities here with the Voronoi with results from OptiStruct. Please just write in the chat if you have any questions, want to dig deeper. Otherwise, I would just go through as an inspiration of what you can do. All right. Then Markdown reporting. So let's see. Let's advance. Let's use it simple. So simple workflow. Again, super academic. The other one is more advanced. Here, everything is based on this FEA. So you have an FEA simulation. Can be this this simple part. Can be something else. It doesn't matter. What you need to do or what set of node you need for this is reporting. Markdown. So you find them also under, I think it's utilities. Let's see, yeah, utilities reporting here. And then if you're a little bit familiar with Markdown, so you can do everything that is available in Markdown. So first you create a Markdown file, and that is then converted to a PDF using the Markdown to PDF. So we basically start with a Markdown heading. And we use the text or the panel notes here to edit this a bit. We set a heading. We have this construct date and time, which takes the date from today, but you can also set another date here. We want a date inside, and then we have some text tools here, format text, for example, where we have placeholders in the text. Here you can see them with 1, 0, 2, and again we use the merge with the list, and these placeholders here are taken from that list. These are just the indices of that list. So in the end, we create a small text that we want to put in our report, and so on. So there's some image, so we can have a viewer screenshot from what we have here. So we can get that view refreshed this year, for example, like this. Maybe it's a bigger difference. Use the viewer screenshot. Yeah, have an image here, and the image is then exported. You will also find that in the files. And yeah, you create the markdown image, caption, so on, so on, so on. Then merge, put everything from top to bottom, what you want to have in the report, create the markdown file, and then the markdown to PDF. And here in the markdown file node, we can visualize the markdown for once, see if everything is set up the way we want it to be. It looks fine. It's like what we have set up. And markdown to PDF here, and then let me check out markdown reporting introduction or PDF. By the way, all these workflows are available in the online academy, so so they haven't been shared. You can just go there and check them out under reporting. That's the simple reporting. Yeah, super simple, can be way advanced. Maybe you remember that from Voigt at the beginning. It's way more advanced, but the basic concept is the same. Okay, then also in the Academy you will find that other workflow. That's the advanced version. So you have some screenshots here that you could add, and the reporting is condensed in this in this node here. So that's embedded, and you can see that the basic concept is the same. So we just add on to each other. It's just a bit more what we want to do, because the report is bigger. Right. Okay, so here I advise you just to go there, Academy, and check out these files. You will find descriptions everywhere. What to check out, some recommendations of templates to use, and so on. Okay. Now we go a little bit away from the parametric design, a connection from CAD to FEM to more advanced stuff. For example, we can modify the .fem deck with some Synera internal nodes. And these are called bulk card nodes, or the deconstruct bulk card and construct bulk card. So, for example, you all know that .fem file, and there are two versions. There's the short and the long format. So the short format has 8 characters for each entry. The long has 16, and you can process both. So when you're familiar with the FEM file, so first you have the I/O section at the beginning, then you have all the case control, the subcases, load steps, and then you have the bulk data section with all the grid points. Here, for example, in this little example, we imported the FEM file, took the Y value of the first of this first grid point, and moved that or changed that Y value in Y direction. And then construct the FEM file again, import it to Synera, and then we can read it out like we do here. Yeah, for this, what we need to do is some basic text matching. So we first search for the grid. As we can see here, we search for this first entry. Then we split that file into 2 parts. Basically everything that is under the bulk data section, everything that comes afterwards. And we take the deconstruct bulk card of this first line always. here, and then we see that, nice, the y coordinate of that grid point actually is the fourth item here, or for the index 4. So that's what we do. we replace at the indice at the index 4, we replace that value with the number 10. So we change this from 8 to 10. So before was 8 was the y value 8. Now it's the y value 10. Here in the bottom, it's just for that long format, but basically it's the same. Then we construct the bulk card again and feed it back into our data before the grid section and the data after the grid section, replacing this item. And yeah, we write a text file out of it, and then we can import it as model. So that's one version. There are even more. So I mean, everything that's in that section you can modify. Here, for example, you could modify the topology optimization variable. Yeah, here we set this level set command at the end. But the approach is the exact same. So in the advanced version, you could do stuff like, especially when things are also not supported in Synera yet, you can go for TCL scripts. That's also possible. And if it's FEM file related, you can go for this deconstruct and construct bulk card nodes. For example, you can make a thickness optimization, a topography optimization, having beats by changing the design variable, the settings of the optimizer. And here, the interesting point is that in the workflow, you don't change it directly. So it's still an FEA setup, a shell thickness optimization, feed it into the OptiStruct optimizer. But at the very bottom of that node, you find this export workflow. And here, this input requires a workflow, right? So behind this and this array here, we hide a workflow that we call, and that is then used just from that node. We just give the information. There is a workflow that is able to convert this, to make this bulk data conversions. And this workflow is located here, and here are the changes that, or the values that I need to take into consideration for the beat creation. And this workflow will be then taken into consideration by running that optimizer. And that's cool because suddenly it's not a thickness variable anymore. It's a topography optimization. Yeah, we don't do it in this workflow, but have a linked workflow, basically, that is behind that. Okay. Well, then there's some. Let's see, yeah, the recording will be shared later.